Okay, I have I have .py files to execute it, and on the left hand side, the data sets which I will be working on. So as a first step, I will just execute the iris.py file, pre-process file, and here is like the beans and number features and number of beans I need for this, and it will convert in the discretization. So I will just go ahead and run this process. And at the same time, I will also initiate the pre-process housevotes.py file as well. It will convert the raw data into the binary format. So I will just run it, and I'm pausing it right now, and we'll come back it in a minute once the processing is done. Okay, pre-processing is done, and we can see the two files are created. So as a next step, I will just kick off the house dot prediction files to do a prediction on the house vote file, and then I will just move it and show you the how the pre-processed file looks like. Okay, files are open now. We can see the iris file is converted into the 10 binary format, like the length and beans and everything is converted, and it's completely 10 format. Pre-processing, the votes file is also now converted into the 10 format, and we have already executed the algorithm for the prediction. So for the winnow, we can see the theta is a zero point 0.5, alpha is a 2, and gives like a 93% accuracy for the 122 correct observation against 133. Well, the naive bias is giving a m equal to 1, and the mp 0.001 and almost 117 observation, which is quite similar, and 90% of accuracy as well. Now we'll jump back to the folder and see like what are the different files has been created, and we will go into each and every detail file. um, uh, okay, I have all the files open now. So over here, this is a train winnow model for each features and the respected weight for that feature for the winnow. And on the right hand side, like there is a naive bias model where the zero class and one class as well, and for each class, the class level probability as well as the feature level probability, and for feature, what are the unique values and their probability for that unique values. Coming back to the other file, which is a training file for the house vote, we see like the file was already in the binary, but then now on the right hand side we see the weight has been added, and the predicted class has been added, and the promotion and demotion process is also there. Yeah, we can see the like a bunch of no operation, demote, and there is a promote operation as well. We can see like wherever it is in this applicable. So it's going back to the another prediction for this for the house vote file, where in the right hand side we can see the weight and the predicted class over here for each weight based on the theta value. So that's how the winnow algorithm is winnow algorithm is predicting for each weight, comparing with theta and giving us the predicted value on the right. And finally on the last one is naive Bayes algorithm, where uh, if we move on to the right hand side, and it gives the class level probability for each instance, like for the zero class what's the probability, and for the one class, sorry, not probability, what's the weight, and for the one what is the weight, and whichever weight is higher, that will be assigned to the instance. So here in this case, first instance, first three instance basically the Republican, because the class 0 is higher than the class 1, and for the fourth one is a Democrat, because the class 1 is has a higher weight, basically higher calculation, so it's a Democrat. So that's all from basically as of now. We discussed about hot encoding, we discussed about the discretization, and we talked about the predictor, how the prediction is happening in the winnow case, and training is happening in the winnow case, and prediction in the both winnow and naive Bayes format. Thank you.